Hi, welcome to my channel. So today we'll be discussing scale drawing. Scale drawing. Scale drawing. By definition, scale drawing is an enlargement or reduction of an object. To enlarge or to reduce an object is called scaling or scale drawing. For example, you can reduce a large 3 meter by 3 meter 3 meter by 3 meter cube into 3 centimeter by 3 centimeter cube. That is reduction. Or you can enlarge a small quantity or a small object by increasing the length and the size. That's enlargement. So scale drawing is an enlargement or reduction of an actual object. So in actual sense, a scale drawing is a proportional to two-dimensional drawing of an object. When you draw an object, or when you reduce a two-dimensional object, you are doing scale drawing. Do you understand? For example, if I have a rectangle whose size is a 3 meter by 3 meter and I reduce it to a smaller rectangle of 3 centimeter by 3 centimeter, I have done a two-dimensional drawing of that rectangle. Okay, so a scale drawing is a proportional two-dimensional drawing of an object, while a scale model is a proportional three-dimensional model of an object. To read a three-dimensional object is a solid shape, for example cuboid or cube. Okay, if you reduce a three-dimensional object, you are doing a scale model. Okay, so we'll continue with our definition. So having known the definition of scale drawing, let us see what we can say about scale factor. Scale factor. So scale factor is just the proportional relationship of the drawing length to the length of the actual object. So scale factor set up the proportion between the drawing length and the actual length. So scale factor equals to drawing length all over actual length. Okay, of course, this is a proportion, a ratio. So proportion have no unit, ratios have no unit. So scale factor is the drawing length, that is the length of the object you have enlarged or reduced, all over the actual length, the real length or the real measurement of the object. Okay, so now let us consider the steps of calculating a scale factor. How do you calculate scale factor? How do you find this drawing length when you have the scale factor and the actual length? How do you find the actual length when you have the drawing length and the scale factor? So step one of solving problem involving scale factor is to set up a ratio. Set up this ratio. You set up ratio H1. Set up ratio 1, which is drawing length all over actual length. Okay, drawing length over actual length. Step 2 is to look at what you are given and set up another ratio. Look at what you are given and set up another ratio. Set up another ratio. drawing length over actual length. Now you have two ratios, right? Okay. Now when you set up the second ratio, step 3 is to equate the two ratios. Equate the two ratios. Okay. Now after equating the two ratios, of course you have an unknown, right? So whenever you have an unknown, it calls for solving the equation. So step 4 is to cross multiply and find the unknown. Okay, so those are the steps of solving problems in scale drawing. Okay, scale, remember the formula: scale factor equal to drawing length all over actual length. Okay, now the unit of measurement of length is very important here. It is very important that you remember the unit of measurement of length. So we have 10 millimeter equals to 1 centimeter. 10 centimeter equals to 1 decimeter. 10 decimeter equals to 1 meter. 1000 meter equals to 1 kilometer. So it is very important that you remember this measurement. You must remember them. So scale drawing, uses of scale drawing or model. So scale drawing is very useful. It's very useful in real life. For example, if you want to paint a room, right? You know you are not going to paint the window, you will not paint the door. So you do a model of the proportion of the room you want to paint, right? In order to calculate the cost of the paint. You understand? So you can use scale drawing problem there. Scale drawing is used in drawing house planning. Okay, if you want to draw a house plan, you have to do scale drawing. If you want to draw in architecture, if you want to draw a three-dimensional model of a house, you have to have the knowledge of scale drawing. So it is very useful in real life application. So an example of reduction and enlargement. Let us assume that this rectangle is not drawn to scale. Let's assume is a square, rather 3 centimeter by 3 centimeter. If I reduce it to a smaller one, let's say 3 millimeter by 3 millimeter, I have reduced this bigger rectangle to the smaller one. Okay, so how do you find the scale factor here? Scale factor. So let's try and find the scale factor of this. Scale factor equals to drawing length over actual length. Okay, the actual length is 3 centimeter and the drawing length is 3 millimeter. So this is 3 centimeter all over 3 millimeter. Okay, so this is a ratio of different units. We can convert it. So this is the same thing as 3 centimeter ratio 3 millimeter. Okay, so you know that 10 millimeter makes 1 centimeter. So this is the same thing as 3 centimeter ratio 30 ratio 0.3 centimeter. Okay, which is the same thing as, if you divide both sides by 3 centimeter, you just cancel this here 1, Let's cancel this. This is 0.1. So the answer is 1 ratio 0.3. 1 ratio 0.3, which is the same thing as 1 over 0.3, which is 1 over 1 times 0.3 is the same thing as 3 over 10. So this is 10 over 3. Okay, so the scale is a 3.3. So the scale factor of this drawing that I have done is 3.3. Okay, so we'll end our lesson here. Next time we'll discuss examples of scale drawing. Till then, bye for now. Do not forget to subscribe for my next video at the bottom of this page.